Alright, guys, as you can see here, I'm on google.com, the very beginning place of learning how to do all things, right? And we'll be creating slash training our very own AI model, like we would behind the scenes, when me and my team are building it out for you. If you have a startup or a app, um, always got to chill. Alright, but yeah, oh, my Google search history here. Let's see. We gotta. And I'm kidding. It's all offering the virus to like, watch out for viruses, guys. Jesus Christ. Like, I don't know if you guys are anything from like crypto, even with chat stuff. And I see so many viruses. Just make sure you check all your files. Virus Total um, is our site. We go there and we can upload our files to see if they have any like reported viruses. So if you see here, I know that for sure this. Did we like double players or did our thumbnail have a virus? No, of course not. Our thumbnail didn't have a virus, right? It's just gonna check it across various vectors, to see if it has a virus. This is not an ad for virus tool. I promise. I just have massive amounts of ADD, right? But it's not a bad idea. Like we could, like what is, just ideating. What if we created like an AI that kind of, oh, I don't know. Stuff like this can already exist. I'm just, going off right now, right? Like, what if we create an AI that, like, mm, kind of just like monitors, like, or monitor our file system to kind of see if like there's any like suspicious things. But I mean, I guess that's kind of already what virus scanners do. I mean, but virus scanners don't always have like the latest stuff, right? So if you can train an AI model, right, on what the potential like virus looks. I mean, this is it sounds like it's very big done. All right, back to the thing. All right, so the first thing I kind of want to do is I want to know like like what does it even mean to like create start training your own AI models. We've seen a lot of these large language models, right? And like you often hear that all the money is going to be made in creating your own AI, this AI, that AI, like whatever. But how do you actually even do that? Like, what does it even mean? So here we are, and on google.com, where all great things start, including what we'll be doing for your project. Even as I can assure you, as like a tenured engineer, it doesn't matter. We all go to google.com. All right. So I wanna hit no. And again, guys, if this video goes on for very long, I may get pretty quiet as I'm thinking. But if it goes on for too long, I'll try to put timestamps, right? But if you do have any questions, please leave them down in the comments or send an email. I also reply to any emails. And lastly, guys, before I get really deep into it, if you are looking for a team to develop your very own apps, whether that's AI apps, Web3 apps, email down below, reach out to me. Me and my agency will set you up with your own team of dedicated developers. All right. Gotta chill. All right. But yeah. So yeah. How do you? Let's see. Llama. All right. So if you don't know, like okay. I was gonna say like I was gonna say like llama, right? Um, like the large language model llama. So if you don't know, llama is one of many um, large language models, right? Like ChatGPT, right? And so with in the current standard of AI, right? There are these large models, different models, right? So you saw ChatGPT in the previous video. This is ChatGPT. This is one, there's llama. I think llama is created by Facebook, and you have Bard, but that's not open source, I believe. Google Bard, and these are all just kind of like different models. Um, I think in the case Llama is created by Facebook. I have never been to this website like ever. Um, okay, we're on the wrong web. No, are we? Check out your banking solutions. Banking, come on, bro. Like what the fuck, bro? Come on. Um, yeah, Llama, created by Meta, formerly known as Facebook, right? Let me quickly download the mod first. I've never been on this website. I have no idea what the heck this is, right? I'm, like kind of just I'm bringing you guys all along as you come with me, trying to not trying to get followed by Facebook here. Oh, right. Give me like a ton of like disclaimers. We will email you. I wasn't looking for no email, bro. Come on. All right, let's go to the email. I get like a ton of spam in my email, so I always fear to come to this inbox. It's like you're like guaranteed um like just check this out. State.com recent hack. I think State got hacked or something like recently. So um anyways, copious amounts of spam. But anyways, this email is pretty tiny. So all right. So let's check out this email. Let's see if what we can decipher from this email. All right. Llama come here. You're all start building with Llama. Model weights available. Code Llama Pi. Code Llama Pi. Blah blah blah. With each model, you download a copy of the license. Helpful tips. Llama downloads. All right. So Llama repository. All right. We have a GitHub link. Insert the following. Alright, so we have a URL, with a code, and we also have a GitHub link. We head over to the GitHub link just because GitHub always has nice information for us, right? So I'm really trying to figure out like what do people really mean when you're like create our own AI model, like um create or tune it. I already kind of know, but I'm just like going down the exploration path, just to like, um, just kind of get a feel for the space, right? I already know, but I still wanna. So yeah, so this is just giving me a ton of instructions about like how to set this up. Um, to be honest, I don't really like this. Let's do better. Large language model. We may also hit some of these YouTube videos. So if I hit your YouTube video, like shout out. So large language models are machine learning models that process and generate human language from training on massive volumes of data. Alright, so basically that just means I give you like lots and lots and lots of text, and through the magic of machine learning, which is, if you guys don't know, it's just statistics and lots and lots and lots of data, to then like come up with a bit like better predictions. Basically, um, it learns to like like interpret and then respond to text, basically, right? So that telling us about ChatGPT. Let's check check our time here real quick. Make sure we're all recording. Yep. A large language model involves an algorithm that has been trained on a large amount of text-based data to return answers to prompts based on relationships between different words. The model is able to learn new skills such as drafting presentations and writing code based on its analysis of the vast volume of data. In addition to ChatGPT, large language models also drive AI tech such as Google Bard, Microsoft Bing, and Meta's Llama. Alright, so to be honest, like I'm not really learning anything extra that from these, searches that I'll tell you about. Actually, or wait, I tell you about. I was just gonna like skip to the fine tuning part and kind of explain, what I was trying to like achieve, but I wanna read. I'm gonna read it to you from here, and then we process. But so so no surprise. Like the first step in creating our own language model or creating a a model. Um, so alright, I was gonna let me read. The first step in building a large language model is collecting a great deal of textual data on which the model will be trained. The text must then be tokenized or broken down into smaller units of data called tokens. Example: on, believe, able. So words for easier processing and learning. Here are a few ways to tokenize pragmatically. All right. So we kind of know this. We just maybe put spaces in between or something. Um, Architecture, right? The next step is to choose the architecture for your model. A popular architecture for a large language model is called a transformer, which uses a technique called self-attention to keep track of relationships between words. Right? Transformers analyze pieces of text concurrently rather than one after the other, as was previously the case, and allow machines to develop a sense of context between words. They have been pivotal as a way for large language models to scale quickly and efficiently through faster and more cost-effective training. A transformer architecture is behind OpenAI's generative pre-trained transfer. All right, so let me put that in English. All right, the large language models they use they remember what you said, right? They store it in memory, and they remember what you said, so that the next time you you say something to it, it remembers what you were saying before and keeps it in mind, and it uses um, it in its processing when it's responding to you in English, basically, right? This was kind of like one of the big features of ChatGPT that made it seem so groundbreaking. Before, like, chatbots didn't really keep track of like the things that you said and didn't understand context, which is, when you think about that, like what is context? That's context is a very like nuanced thing. It's a thing we often only associate with humans and other intelligent animals, that like they can remember like who you are, what you said, the relationship that you have, the relationship between what you say now, between what you said like an hour ago, yesterday, right? These have all been historically contained like rather intelligent beings, as we perceive it. But now when we combine that with or the machine learning from these large data sets, then we have something that can seem quite intelligent, right? Training. The model now must be trained on the text data to predict the next token in a sequence. Mathematical representations of text called parameters. Let's read it again because that word parameters is important. Um, Mathematical representations of text called parameters help the model learn the relationships between words and improve its performance. The more parameters a model processes, the better its performance in mimicking human language. For example, ChatGPT was trained on 175 billion parameters, making it 10 times larger than any predecessor. I read 125 different 175 billion parameters as like words. So is that what it means? 175 words. Let's click on this link, to kind of find out. Oh, what I use this article. Wait. Okay. So I mean, it's pretty useless, but yeah, I pretty much just take parameters to mean words or tokens. Well, I mean, I guess maybe that's why they call it in parameters. If we're talking, if you're training in code, I mean, there are like full stops, commas. So I mean, okay, that's a reason to call it something other than words, I guess. Fine tuning. Once training is complete, a process called fine tuning adjusts the model's parameters to perform natural language tasks for specific industries or functions, such as for scientific research or financial fraud detection. Fine tuning takes a pre trained model and adjusts it to new data to achieve a certain level of performance without needing to start over. All right, so this is really in my view what I think we'll be doing, what we'll be doing, what we think we'll be doing a lot in this series, which is fine tuning. Right, this is where the real magic comes in, because to do all the other stuff really is kind of recreating the wheel, and then we probably will be recreating the wheel poorly, because it requires a lot of time and compute power and thinking, and really the power of these models, the power of these AIs, if you will, simply put, is this, right? We can talk to them in natural language, whether that's voice or text, right? Usually text now. We can talk to them in natural human language, including making mistakes and stuff like this, right? And they can understand what we mean. They can have a base guess, like a base guess, a prediction, a statistically significant, to say that in my like math terms, so all the computer nerds, a statistically significant guess, right? And based on experience, right, from all the previous examples that it's seen, right? It can understand what we mean. So we can say something, and it can understand what we mean through that methodology, and then it can say something back to us in that human in that standard human language, right? In that human readable way. So this is really the power of what is considered these current versions of AIs. You know, we're talking about the large language models here, not there are other types of AIs that will like create images and stuff like this, right? We're talking about just the large language models here, right? And all their natural extensions, right? Um, this is the power in that we can talk to them and give them our data as text, and they can learn it, right, and then be useful to us later, right? What we call fine tuning, right? So in this video, we kind of really be fine tuning about creating makes a better headline. All right. So that's the thing. Just imagine like I have my notebook, for example, right, and I have, you know, like lots of notes there, that things that I've learned over the years. What if I could give that to an AI, right, who could remember all that data, and then the next time I run into a problem, or I wanna remember some things that I said on a topic, or something like that, I just say to the AI, hey AI, show me all the examples of times where I had a problem with this, or hey AI, what is the you know, yeah, I don't know, like give me some advice, you know, on dealing with this, right? And it can like process everything that it knows from my notebook and give me an answer that, you know, should be as smart or smarter than me based on like all the data that I've collected, right? Similarly, you know, can imagine for like large companies, stuff like this, you know, for from all their like, I don't know, like let's say, I really don't know, but like let's a large company or something. Let's say an accounting firm or something, like who are constantly, you know, like talking to customers and reading reports and stuff like that. What if they can just say, hey, large language model, read these 100 reports and give me like 100 summaries so that I can send those out there, you know, you know, cut down all the words and give me all the, you know, the critical information, right? Like that's something that that model might be able to do, right, once you've given it the right data and it has the right training, which all of these models already have, right? So that's really the power of it here, being able to give it your own information, just like, we were able to give like social media sites or information or pictures or captions, right, or videos, right, and like have that broadcasted out to the internet, and then they can, you know, sickeningly like using to advertise to us all the, you know, like, arguably better, you know, better advertising than what we had before about things that we might be interested in. So the large language models are a way for us to give it, you know, our data, and then like it's able to assist us, right? So no Terminator stuff yet, but you know, we're getting, you know, very close to the human we're getting better at the human interfaces and mimicking for sure, right? So risk of language models, yeah, we don't care about that. Obviously, we know it's already Terminator 2 on all of us in a few years. Like, let's be real. Um, Large language models and search. Obviously, this has many implications to search, because now instead of, you know, knowing what to search, maybe you can just say in human language, I don't know about such and such. Can you tell me about such and such, or, you know, and stuff like this. And so, um, yeah. So that's all kind of about large language models and like what. Um, Wait, let me go on some more links. You know, I always like to make sure um, my I'm intaking the best C LLM models online. I also know something from the site that there should be some site with all the models um, that are currently out there. So we see Llama, B1, B2, Red Pajama, I don't know, Wizard Mask. So you know, you have all these different models here. Just kind of just kind of going through really quickly to see if there's anything go for any of your opponents. Let's see if there's anything I'm like missing, but I think we already have the key point here. um, Just Google some terminology that I'm not sure about. Alright, so this is really some like more base level stuff. Um, alright, I'm curious. I just want to see this. Okay, it's just more some base level stuff that has to do with the actual heavy lifting, which is not necessarily what we are going for now. All right, so I was just clicking around real quick, making sure that here we have a nice little graph of the top large language models. I think a lot of these are also open source. So WuDao has 1.75 trillion parameters, right? Words, right? MTLNG 530, Bloom 176, ChatGPT 175, and I think they have more now with GPT-5 plus DeepMind 1.18. Um, see, we also have a graph here. I think it's pretty interesting. Um, Look at this here. The architecture of large language models such as OpenAI's GPT-3 is based on a type of deep learning called the transformer architecture. It consists of the following main components. See figure 1. So figure 1, we have our uh, text and embed, right? Or text, right? We have text and text and embed, which I guess is input, right? Max, multi, self attention, layer norm, feed forward, layer norm, task classifier, task prediction. Interesting. Okay, and by interesting, I mean you have no idea what the fuck I just said. Um, but we have inputs then, multi-head attention at a norm, forward feed at a norm, positional encoding, output embedding, multitask, blah blah blah, at a norm, linear softmax output. Okay, very, very, very interesting. All right. The input sequence is the first transformed into a dense vector representation known. Input sequence is first for the core component of the transformer block architecture is the multi-self-attention mechanism, which allows the model to attend to different parts of input sequence to capture its relationship and dependencies. Alright, so basically it's looking at our text, kind of in parallel. We're gonna see connections between various parts of it is what I take from that. After the self-attention mechanism, the output is fed into a feed for neural network, which performs a nonlinear trans into a new representation. Okay. Stabilize the training process. The output from each series normalize and residual connection is added to allow the input to be passed directly to the output, allowing them to learn which parts of the input are most important. These components are repeated several times to form a deep neural network which can process long sequences of text and generate high quality output for various language tasks such as text generation. Represent to develop our models by implementing new techniques to simplify the model, improve lower price, decrease model training time, training large models, data collection, obviously, model selection, use transformer deep learning architecture, which is the common choice recipes. Some key components are number of layers in transformer blocks, number of attention head, loss function, hyperparameters. Model is trained and pre-processed text data using supervised learning. During training, model is presented with a sequence of words and is trained to predict. In training, the model is presented. Alright, so this is interesting. During training, the model is presented with a sequence of words and is trained to predict the next word in the sequence. The model adjusts its weight based on the difference between its prediction and the actual next word. This process is repeated millions of times until the model reaches a satisfactory level of performance. Alright, so there, I think there you can see a very simple. In this sentence, you can have a very simplified model of what we were kind of being shown here. which is like, all right, how do you actually train this thing? Like once you have all this data, and you do that by kind of, like, all right, this is what a word is, or this is a word, and then you kind of say, hey, like, go look at this word and this word and maybe this sentence, and try to guess the next sentence or the next word, and then you can compare to say, okay, how many times did we see this versus that, and you can look and see versus the the reference data that it has that we fed it. Okay, it was able to predict with such and such amount of accuracy, indicating that it understood the natural language, right? So that's a very high level, like simplified way of saying, how this is how we might train um, train models. Called different parts of the GPUs along the model between parallel evolution and fine tuning. After training, the model is validated and tested as it will not be. Training estimation was based on the evolution. The model may require some fine tuning by changing the architecture for training. Alright, so then it kind of tunes it once it has proper understanding of words. Training of LLM, a large language model consists of two parts: pre-training and task training. Pre-training is part of training that enables the model to learn the general rules and dependencies within a language, which takes a significant amount of data, computational power, and time to complete. The large, let me just check real quick. The large language models discussed in the paper require super the large models discussed in the paper require supercomputer systems with several AI chips. Once maintenance and power costs are added, pre-training of a large language model is an investment in the magnitude of millions. To make large language models more accessible, enterprise large LLM developers are offering services for to make large language models more accessible for enterprises. Large language model developers are offering services for enterprises looking to leverage large language models. NVIDIA's NeMo is an example of these services, which offer pre-trained large language model for fine-tuning and specific task training to suit specific use cases. The specific task training adds an additional layer to the model, which requires much less data, power, and time to train, making large models accessible for enterprise use. The new task specific layer is trained with trained with few shot learning, which aims for accurate outputs with less data training. Alright, so the way I kind of read that, and the way you should kind of read this, is where all these open source models come from is, companies like NVIDIA, Facebook, Google, who can afford all the data and GPU power, processing power that it takes to just teach the model basic English, if you will, English, Spanish, like whatever. Just to teach it that, requires an immense amount of data and training, and like, then once you teach, it's like, like just like you teach a human, right? Like you teach them some English first, and then maybe you teach them poetry, right? Or you teach them story writing, or you teach them what's another thing with English, I don't know, um, poetry, poets, I don't know, you teach them songwriting, like after you teach them English, right? So that's what they mean by specific training. So general training is like learning the language, learning how to interpret, like what is meant when it gets a certain input, and learning how to give that back in English, right? So learning English, let's just to simplify it. And specific training is like teaching how to write songs or how to write poetry, like how to be creative, like write a story, right? And all those sorts of things, right? And so that those are kind of the two foundational layers of the ecosystem right now, which is like these pre-trained models, and then being able to fine tune, which is kind of like what we'll be looking at a lot. All right. Um, Alright, so this is just a little video here telling us about NVIDIA's little model. If it's not too long, then I'll watch it out. with you guys, and then we will jump into fine tuning our very own on our own data set.
Conversational AIs are opening new opportunities in every industry by automating tasks with apps like chatbots and virtual assistants. But it takes a lot of effort to build the models that run beneath these applications, and there are many models that go into a typical conversational AI pipeline.
Make this big for you guys.
Enterprises and academic institutes are in a race to produce the best models. So, researchers are on tight deadlines to achieve state of the art accuracy on tasks like recognizing speech amidst noisy data, understanding nuances in human conversations, and generating human like speech to deploy in a production environment. Current frameworks provide low level APIs to build the models, which requires researchers to write a lot of boilerplate code, non semantic connections, and hooks to make a model. Also, many existing frameworks support building speech recognition, language understanding, or speech synthesis models, but few seamlessly support all three. Nemo is a focused toolkit that lets you build a full range of language and speech models. Nemo simplifies the development of complex neural network architectures for conversational AI. It breaks down the monolithic flow into reusable neural modules that take typed input and produce type output. Models, encoders, decoders, language models, loss functions, optimizers, and much more are just a simple import or an edit in a config file away. Neural modules can be reimagined as Lego blocks that can be used to construct a neural network. Nemo is built to work on top of PyTorch and PyTorch Lightning. So for example, you can import a QuartzNet model for automatic speech recognition, a BERT model for natural language processing, a Tacotron model for text-to-speech, and the loss functions and optimizers you want from Nemo or PyTorch. Then, you can use the customized PyTorch Lightning data loader and schedulers you wrote and train as you see fit. Nemo also works quite well with Facebook's Hydra and can meet your customization needs for each model with simple changes in a config file. There are multiple ways to get your hands on Nemo, through NVIDIA NGC or pip install, or simply build it from GitHub. Let's have a look at the Nemo resources available on NGC. In the catalog, you model up and running is a simple 3-step process from GitHub repository. Either you can get the stable version with pip or install the nightly version with GitHub. Check out the GitHub repository like that. You can define the input features, filter 6 things to consider and decoder. You can define the input features, filters, kernel sizes, and more for each layer by simply adding some text. This enables easy access to various networks. Say you want to read here, we are adding an exclamation mark to the GPUs. We would like to leave you with 4 key takeaways. Nemo helps simplify and abstract the complications of building a conversational AI maximizability.
Yeah, so basically this was kind of just teaching us about NVIDIA, which is a leading player in the AI space, right? About their own language tools and like how we can use it to also fine tune our models. All right, guys. So the summary of this video is there are a few players in this large language model AI space, right? And remember, a large language model is just a form of AI like this or ChatGPT, right? This is a large language model slash AI slash chatbot, right? So there are a few players. They're doing there are a few players, right? They're doing a couple different things. And key that they're making things easier, and we'll be checking out those players in the next video, but also we'll be getting into fine-tuning our own model for our own uses, which is something that can be interesting. All right, so again, quick reminder, guys, if you do want your own engineering team to work on your own startup idea, your own web or applications project, email down below. My agency will set you up with your own custom not to be confused with a theme like our dark theme here. We'll set you up with your own custom team of professional developers vetted by me, that will help you see through your vision. All right, guys, so this has been our video kind of checking with a little deep dive into large language models AI, and we'll continue the series in the next video somewhere here or there. here. See you guys.